So now in this video we're going to look at a relay component. So they actually come in modules that are much easier to use, but we're just going to look at the bare component there. So we have a coil right here that indicates that part. There's a outline there to indicate that it's a single component. Hopefully you can see that. Here is a mechanical switch on this side, mechanical switch on that side. We're only going to use this side right here. We're going to just leave that one floating, not connected to anything. But in any case, the middle pin is the common pin. So when we don't have the coil energized, it connects these two pins together. It's a mechanical movement that disconnects when we apply a current through the coil, so that it goes and moves over there. So it connects these two right there. So it's a mechanical movement, mechanical switch that actually does the switching, but it's controlled electrically. So it's an electromechanical component. It's got an electric part and a mechanical part, but they're separated. There's the magnetic field that the coil builds up that switches the switch from its normal state, which we see here because that's normally closed and that's normally open, and that's when there's no energy going through the coil. We add energy, that is when it switches. So you can see that's normally closed. The switch is in the resting position. So I got the flyback diode here because we have an inductor going through there. It doesn't start flowing current instantly when you close the switch and apply power, and it also doesn't stop instantly when you open the switch. So when you open the switch, that current needs somewhere to go. It'll go through this diode, which is reverse biased to the power supply. So current won't flow through the diode when the switch is closed, but when you release the switch, it gives a return path from the coil to go through the diode like that. And zooming back, you can see I'm using my 5-volt breadboard power supply to power the breadboard. It powers both rails independently, but you can go positive from one side over to negative to the other. But in any case, we're only using that side anyways to power the circuit. We have the coil down there. I'm going to just touch the alligator clips from this power supply to the two sides there. So doesn't matter which way the current goes, but since we have the diode like this, the cathode's there, we want positive touching that side of the diode, and then we'll do a negative to that side. And there you can see current flows through the coil, and there you can see it's about 44 milliamps. And if you use a 5-volt coil, the 12-volt rating is for the coil, then you'll get a higher current. It'll take more current, about the same power. I looked at that a long time ago and found that to be true. So the higher the voltage of the coil, the less current. It seems to be about the same power supply. So in any case, for DC, this says 30 volts, 5 amps. That's how much it can switch. You still use 12 volts for the coil if you have a higher voltage power. We actually have a lower one in this video. And it says 240, but I don't know how you would wire that up with this setup. But 240 also, 5 amps for AC right there. That's alternating current. But I would stick with DC current using these and the lower currents. You can get modules though that are much more useful. But this is good for the demonstration. So I hope you enjoyed.